Hello everyone, it's Tez Cybernoob, and today I'm going to be talking to you about subnetting in the last octet. In the previous videos, we talked about how we use classless interdomain routing and how subnet mask is what defines our network rather than using a class to define the network. I also showed you the different ways to view a subnet mask: a prefix, a normal subnet mask, that is what we use to read this, and the binary equivalent of the subnet mask and the prefix. The prefix is just a short way to determine the subnet mask, or to identify the subnet mask. Today we're going to be talking about subnetting in the last octet. We know that a /24 is just telling us how many network bits are in the 1 position from left to right. There's 24. So we can actually keep going with this. We can make a /25 or a /26 and turn these zeros into ones. Now, if you're wondering why we might need to do that, we don't always need a network that has 256 addresses on it. Sometimes we need a network that only has 16 on it, or 8, or 32. For example, let's say we were given this address, 192.168.0.0/16. So we know the divider is right here. And we were told to subnet this into 4 groups of 32. Sorry, not 4 groups of 32, but into 4 networks. And each of those networks have 32 end devices on them. Let's make this a little easier and say that they have 30 end devices in each network. Now we can make this really easy and say that each of these networks is 192.168, and then we can just do a .1.0 for network address, and then go down, subnetting them all like this. Yes, this would make it very easy to do it like that. But each of these has an option for 256 different addresses. Now let's say we were given this public IP address. We were told that we need to subnet it into 4 networks to hold 30 different end devices on each network in a data center. And we are using public IP, so we don't want to just use a bunch of addresses that are unneeded and have those unused in networks. So I'm going to show you how to make it easy to do the math to figure out what the different network identifiers and host addresses are. Now let's say we were given this public IP address and we were told that we need those same 4 different networks with 30 end devices in each network. So we're going to subnet this in the last octet to make 4 different IP address or 4 different network addresses that will allow for 30 end devices. We do this because we don't want to waste public IP addresses. We want to use as little as possible. As you know, we're running out of them and they're expensive. So pretty much what we're going to do is borrow bits from the last octet. You can do this 2 ways. You can calculate it if you know the number of networks you need, or you can calculate it if you know the number of IP addresses you need. And we know the number of IP addresses we need. Let's say we're going off the number of networks we need. We need 4. And that would look like this, with the rest zeros. If you're wondering how that gets us 4, that's because we have 4 different options with this. We have 0, 0, 0, 1, 1, 0, and 1, 1. These are 4 different network addresses. Another way to see that would be 2 to the power of however many bits you're going to borrow. So here we're borrowing 2, so 2 to the power of 2 is 4. Now, since we're going from knowing how many end devices we need, we're going to start from the right and work to the left. Starting from the right to the left, 2 to the power of 1 bit is 2. 2 bits, 4. 3 bits, 8. 4 bits, 16. 5 bits, 32. Now 32 is in the range of number of IP addresses that we need for each of these networks. So we know we need that many host bits, and host bits we'll leave as zeros. Now we only need 4 networks, but this is going to give us 8 networks. And you can figure that out the same way. 2 to the power of 3 is 8. And 2 to the power of 5 is 32. So we have an option for 8 networks, each with 32 different IP addresses. But if you remember, the first address is the network identifier, and the last address is the broadcast address. So we'll take those off, -2, and we get 8 networks with 30 usable IP addresses. Knowing how many total IP addresses we have in each network is what's going to help us identify each of the network identifier addresses. The first one's going to remain the same, the .0. The second one is going to go up to 32. The third one, 64. Fourth one, 96. Fifth one, 128. Sixth, seventh, and eighth. Now these are no longer going to be a /24. The subnet mask for this is now going to be this with this in the last octet. If you watched the last video, then you know how to convert this to decimal format, which would look like this. The prefix is no longer /24. If we take these 24 bits here and add these 3, then we get /27. And a /27 is the same thing as 224 in the last octet. So now we can choose any of these addresses to give to any of these networks. I'm going to give you the tools you need to be able to figure out any network within the last octet. And it'll be a lot easier than this was. You just need to be able to draw this chart. So from right to left, start with 1 and multiply times 2. All the way across until you get 8 numbers. After you get that, take each of these numbers and subtract it from 256. (256 minus 128 is 128. 256 minus 64 is 192. 256 minus 32 is 224. You just keep doing this all the way down until you have 8 numbers again. Now we'll write down the prefixes. Since we're working in the last octet, we know that everything to the left is going to be 1s. So that would be a /24. And then once we get into this octet, we got a /25, /26, 27, all the way down to /32. Now there's 32 bits in an IP address, so it ends at 32. This is the last octet, 25 to 32. If you remember how to write this down, you'll be able to figure out the network of any IP address and even how many host IP addresses there are and what the starting and ending IP address is. Just remember how to do this. I'll show you an example now. All right, so let's say we were given this IP address with this subnet mask, and we want to figure out all of these parameters. Remember, we're only working with the last octet. So we need to figure out the network identifier. To do that, we use the chart we made. We see that our last octet of the subnet mask has 224 in it. So we'll find that over here. Something I should have mentioned, this top row is the group identifier. So it tells us how many different IP addresses are in each network. Since this is a /27, we know that there's 32 different IP addresses in each network. So to figure out what the network address of this IP address is, we just get the IP address. We change this last octet to a 0. Now we'll go up by 32 because that's how many IP addresses are in each one. Since we're starting at 0, 32 IP addresses away from that would be 32. Or it would be 31, and the next network is 32. And just keep adding 32, 64, 96. Now that we've passed the address that we're looking for, 83, whenever we went from 64 to 96, we know that 83 is in the .64 network. Now we know the network ID. This is the address that will identify the network. So the first usable IP would be .65. The last usable IP, well, we'll start with the broadcast IP. The broadcast IP is going to be a .95. Now, the broadcast IP is the last IP address in the network. If you're wondering why it's not 96, it's because the network address is .64. And there's 32 different addresses in each network. So there's 32 different addresses in here. The .64 is one of them. So we'll add 31, and that would be 95. Over here, whenever we're adding 32 to each of these, that gives us the next network address. So .96 is the address of the next network. So we can put that here, .96. Since we can't use the last address because it's a broadcast address, then the last usable address is going to be 94. Now the number of IP addresses in the network is what we figured out up here. It's 32. Oops, 32. Number of usable IP addresses, what we just talked about. There's 30. You can't use the network identifier because that identifies the network, and you can't use the broadcast IP because that is used for other things. The subnet mask is a .224 in the last octet. I want you to go ahead and draw your chart and make a random IP address and a random subnet mask using the last octet and figure out all these parameters of that IP address. With this chart, it makes it really easy. So whenever you're taking your test and they give you that piece of paper that you can write on or that whiteboard, draw that chart down. By the time I'm done with this series on subnet masking or on subnetting, you will be able to figure out all the parameters of a IP address in 1 to 2 minutes, which will be useful on your test. So I hope you've learned a lot, and I'd like to thank you for watching.